let's see another problem. So this also appeared in the year 2021 in paper 1. So here we are given that there are some positive angles, positive valued angles. Okay, so basically these are all positive, and such that their sum is going to be 2 pi. Next, we define complex number z1 as e to the power iota theta 1. Okay, so z1 has unit magnitude and it lies somewhere on this complex circle. Then next we have that for k equals 2, 3 up to 10, I have zk equals zk minus 1 times e to the power iota theta k. So basically it's like z2 being e to the power iota theta 2 times z1, z3 is e to the power iota 3 theta 3 times z2, and so on up until z10, which equals e to the power iota theta 10 times z9. So basically if I have to plot z2 here, it will lie and it will make an angle of z2, it will make an angle of theta 2 with z1, right? So they will all lie on this unit circle. And finally I have that z10 is e to the power of theta 10 times z9, right? So essentially if you see, my z10 is going to be like z9 times e to the power theta 10, which equals z8 times e to the power theta 9 times e to the power theta 10, right? And so on. If I like continue, I'll see that z10 is going to be z1 times e to the power theta 2 up to e to the power theta 10, which equals e to the power theta 1 times e to the power theta 2 up to e to the power theta 10, which is nothing but e to the power I times sum over j theta j, and this we are given that this also equals 2 pi, right? So this is going to be 1. So z10 is going to lie at 1. So z10 we know is 1. Okay, so we are given now 10 points on this circle, and now we are given two statements p and q. So the first says that mod of z2 minus z1 plus z3 minus z2 up to z1 minus z10 is less than equal to 2 pi. So basically this mod of z2 minus z1 is the length of the chord joining it's the length of the chord joining z1 and z2. Next we have the length of the chord joining z2 and z3, and so on until we have finally the length of the chord joining z10 and z1. So we have the length of these chords and we are given that this is less than equal to 2 pi. So let's look at the first assertion, which is p, and let's see whether it's true or not. So there's two similar assertions, p and q. In q we have similar to p, but now the complex numbers are replaced by their squared values, and we need to tell which one is true and which one is false. Okay, so let's look at the assertion p first. So here we are given the length of the chord, and the assertion states that the sum of these lengths should be less than equal to 2 pi. So let's see whether this is true or not. So now if we see, suppose if I look at the chord joining say z1 and z2, okay. So mod of z1 minus z2. So now we know that z2 is going to be z1 times e to the power theta 2, right? And we have z1 times 1 minus e to the power theta 2. So notice that all these points, they lie on this unit complex circle, right? So all these zi's are going to be 1. And now we have to compute these values, right? And actually there is a standard way to compute it, which is that you can take out e to the power iota theta by 2 common. So note this trick. So this will be used in a lot of problems, that whenever you see like 1 minus e to the power iota x sort of a thing, you can try to take out e to the power iota x by 2 out, and next you will see that this is going to be e to the power minus iota theta by 2 minus e to the power iota theta by 2, and the mod of this thing. And this quantity is unit mod, so you know that mod AB is equals to mod A times mod B, so this is 1. And now we are left with the other part, and this, if you see, this is just minus twice I sine theta 2 by 2, right? Because this is a negative of negative iota times twice the imaginary component of e to the power iota theta by 2, right? Because if I want to compute them, if I want to do like z minus z conjugate, I get twice iota times imaginary part of z. So this is what we have gotten, and this is nothing but twice times mod of sine theta 2 by 2, right? And theta 2 is positive. So yeah, so basically, yeah, so this is the magnitude of this theta 2, and we now know that mod sine x is less than equal to mod x, right? So you can see from the figure of sine x also that the mod value of sine x, the positive part of sine x, you see that it's always lies below x, and the negative part is always greater than equal to minus x. So basically, yeah, so if you compute like mod sine x, which will have the positive part only, then it will be less than equal to mod x. So essentially, what we have done is that so we have said that the length of these chords is actually less than equal to the length of the corresponding arcs, right? So you can actually give it a very geometric interpretation also, because the length of each of these chords is what is given by mod of z2 minus z1 or zk minus zk plus 1, and the length of these arcs is given by just the theta case. So because these arcs are in radians, so you can see that length of chord is also always less than equal to a length of arc, and so basically this chord length is less than equal to theta 2. Similarly, similar logic if I apply, then I'll get that the remaining chords, they are also less than equal to theta 3, theta 4, up to so on, and this chord is nothing but this subtends an angle of theta 1, so here this is less than equal to theta 1. So the sum of these chords is less than equal to their corresponding arc lengths, which is up to theta 1, and it is equal to 2 pi. So you can look at it both in terms of geometrically or in terms of algebraically also. We saw that 1 minus e to the power iota theta is less than equal to theta in terms of magnitude. So if each of these is less than equal to their corresponding theta case, then if you sum them up, that will be equal to 2 pi. So the sum of these chords lengths is upper bounded by 2 pi. So definitely P is 2. Now let's look at the assertion Q. So in assertion Q, what we have is that the points are replaced by the squared values. So if you replace the points by the squared values, it's just that the angles and the differences are now going to get doubled, because these are unit magnitude complex numbers. So if you square them, they'll still remain unit magnitude, but the angle, the argument will get doubled. So if the argument will get doubled, the difference of arguments is also going to get doubled. And essentially, now what is going to happen is that this mod of z2 square minus z1 square, this is less than equal to twice of theta 2, next you have twice of theta 3, up to so on, and then you have twice of theta 1. So this is actually equal to 4 pi. So Q states that the sum of differences of squares is upper bounded by 4 pi, but that is also true, right? So both P and Q are true. C is the right option, right? So just think about it, work out the Q part also. So it's just a similar logic, right? So I didn't actually derive the entire result for Q, but the idea is similar, and you should actually try to complete that yourself.